Hello, everyone. Welcome back to my series on the life of an average Oxford math student. And this in this video, we'll be covering my thoughts on Hilary week 2. And it has been a very intense week. There's been I had about 7 contact hours, like tutorials, this week, and the reason for this, I think I might have explained this in the last video, is that essentially we have tutorials covering the last sheet of all the courses in the last term, and then tutorials for the collections that we had at the beginning of this term, and tutorials for obviously the problem sheets that we are doing this term. So yeah, lots of tutorials, 7 hours worth of tutorial, but I think it will probably be more chill next week because we don't have any leftover content anymore. We don't have collection tutorials to do anymore, so we should be good. And the modulus this term, as last term we had 5 courses. This term we have 6 courses, but 2 of them are short courses that basically combine to form one course, kind of like there's the same module, if that makes sense. So the first course we have is analysis 2. And then linear algebra 2 and group theory are the 2 short courses that kind of merge. They each take up 4 weeks. And then we have multivariable calculus, Fourier series and PDs, and dynamics. And my thoughts so far are analysis 2 is very similar to analysis 1 in basically in the sense that instead of working with series and sequences, we're now working with functions. And a lot of it is very, very similar. And also very similar in terms of difficulty. Very consistently quite difficult. There isn't any questions there isn't any free questions, right, that you can on the problem sheet that you just, this is easy, I'll be able to solve this in like 2 minutes. No, they will all make you think. It will vary a little bit on how long it will take you to solve, but it won't be too short amounts of time, or at least it wouldn't be more than like one question that's like really easy to solve. Also there wouldn't be like 3 questions that are impossible, right? Maybe there would be one that is quite difficult, but then you can also solve it, and also none of it is particularly impossible. But still quite difficult in overall. Linear algebra 2 so far has been really chill, but I feel like it's gonna pick up the pace. We'll see what happens though. Multivariable calculus has been really chilled so far. It's not too difficult. A lot of it is revision from last term, but the thing is, I know for a fact that this course is gonna get really difficult, and I know this because I've talked to second years, and out of the second years that I've asked this question to, the consensus is that analysis 2 is the hardest course, or no, not analysis, just analysis in general is the hardest subject throughout the first year. Even though my personal opinion suggests that geometry was a little bit harder than analysis 1 in my commerce. But yeah, analysis 2 is analysis in general is unanimously agreed to be the hardest course, but multivariable calculus is a very close second, and that is a little bit scary, I have to say. But so I know that this course, multivariable calculus, is certainly going to become really challenging very quickly. I'm just kind of enjoying the calm while it lasts. Dynamics is very different. Essentially it's a physics course, if that makes sense, and there's some differences. Like what I've noticed about math lectures, a lot of them, is that whenever possible, instead of showing like the demonstration and giving you something like a fact to know, to remember, or relying on like solving an equation, a lot of the times it's more conceptual, like, oh, just think of it this way, like give you like a analogy of sort. Like mathematicians don't really like to get their hands dirty to actually like go into the hard like derivations or calculations. Dynamics is not the same. Dynamics very quickly, like, it's just jumps straight into like really like grinding calculations, and Like for example, there's like we were learning this thing about stable and unstable equilibriums, and I think there's a very easy way to intuitively understand it. Like within a field, right? Like you can think of it like um, yeah, basically within a field, the if the direction of the force lines up with displacement, then it's unstable, right? And this can be like thought of just like if you had an object like a ball, let's say, on top of a hill. Like at the top of a hill, it is tangent, so there's no force. It's the tangent is horizontal, so there's no force in this. But yeah, but anywhere like if it had velocity at the peak, then and it goes to somewhere like slightly off the peak, like any small displacement away from the peak, this displacement will grow because obviously it's gonna fall down the hill, right? So it's gonna get further from the origin, the equilibrium point, as and the further it falls, the well, not the more force it has, but the force is still like push. The force is essentially trying to get you away from the equilibrium. Whereas, like if it was at like the valley, then it was if like the object is in a valley, then the force is trying to get you to the equilibrium, right? So this is like the difference between like a the intuitive way to see the difference between stable and unstable equilibriums. But the lecture was not interested in telling us like this intuitive way of thinking about it. The lecturer just went, straight into solve the PD, and you will see if this constant is positive, then it's unstable. If it's negative, it's or no, if it's positive, it's stable. If it's negative, it's unstable. And yeah, just dived into the not the P. Did I say PD? No, I meant OD, like the ordinary differential equation, and just solved it, and just went into the calculation and found let's say criteria about constants and whatnot. So yeah, that's I can see the difference. And the last course is of course Fourier and PD, and so far it's a little bit confusing, right? Most of what we've done, a lot of it is even, odd, and periodic functions, which are like stuff we've covered in high school to a certain extent. Obviously, we're covering it again with a lot more rigor, with a lot more depth, right? But that's mostly what it has been about. There's a little bit of there's a little bit of exposure to Fourier. I wouldn't say that we have no idea what Fourier is, series is. We've seen Fourier series. We have some idea of, like, for example, how to derive it or whatnot, right? We're getting like familiar with Fourier series. We have yet to see PDs at all in this course, which I'm not complaining about, and I hope that lasts for as long as it could. But I think it won't last for that long because I think the point of the course is to use Fourier series to solve PDs. I think that's at least the point, the idea. Anyway, yeah. Other than that, the academic stuff. Big win this week in volleyball against Imperial. Probably the most important volleyball match of the season. Essentially, if we lost, we would have had to play in the relegation tournament against whoever is coming up in the second league, probably UCL, and apparently we would most likely have lost. But no, we did not lose against Imperial, so we probably don't have to worry about relegation tournaments because Imperial would probably have to worry about that. Essentially, yeah, we went to Imperial. It was an away game, yeah, and it was it played out almost the same way as the home game against Imperial played out for us. We in the home game we lost the first two sets. We came back, won the second set in the third set and fourth set, and then we lost in the fifth one again. 3-2 loss in total. We did the exact same thing to them. Very, very intense first two sets. It was like 22-22, I think, for both of those sets, and then we pulled away just at the end. And then third and fourth set, I don't know what happened. I think our heads was just not in the game, or we got really tired or whatever. Just lost, how the first two set was close. Well, the third and fourth set were not very close. Like we got just destroyed. But fifth set comes around. Everyone showed up. Everyone realized. I think that we perform better when our backs to the wall, and then yeah, we played really well. It didn't start very well. We were like uh 3-6 down, and that's not great when we're playing to 15 for the first set, obviously. But yeah, we came back and made it was really close at one point. Like it was 11-11, and then we pulled through, which is really really good. But yeah, great win for us. Probably not going to be relegated, so happy days. But yeah, I think that'll be it for this video. Leave a like and subscribe if you enjoy the content. And please comment down below any suggestions, constructive criticisms that you have. And meanwhile, see you all next week.